to educator.com. Today we're going to be discussing equations with absolute values. Starting out with the definition of absolute value. The absolute value of a number x, which can be written as this, the absolute value of x, is the distance between x and 0 on the number line. Thinking about what that means. What I'm saying is it's the distance between whatever x is and 0 on the number line. This is easier to understand using numbers. For example, if I asked you what the absolute value of 5 is, I could go look on the number line and say, okay, 5 is 1, 2, 3, 4, 5 from 0 on the number line. So the absolute value of 5 is 5. I could then ask you what the absolute value of a negative 5 is. And you could look at the number line. And you could say, okay, negative 5 is here. 1, 2, 3, 4, it's 5 from 0 on the number line. So the distance between negative 5 from 0 is also 5. The distance between 5 and 0 on the number line is 5. So the absolute value of both of these is 5. So absolute values are positive. For 0, the absolute value of 0 is 0 because it's 0 from itself on the number line. This is describing what I just explained up here using my example of 5. And what this is explaining is that if the absolute value of x is n, then the distance between x and 0 is n units. So if the absolute value of x is, say, 3, then I know that x is 3 units from 0 on the number line. Okay? What this is saying is that x is 3 units from 0 on the number line. Well, that means that x could be 3 because 3 is 3 units from 0 on the number line. However, x could also be negative 3 because negative 3 is 3 units from 0 on the number line. So if I know that the absolute value of x is 3, that tells me how far x is from 0 on the number line. But I don't actually know if, just from looking at this, if x was positive or negative because it could have been either. If I look at 3, the absolute value of that's 3. If I look at negative 3, the absolute value of that is also 3. So either one of these values for x would give me this absolute value. The absolute value function for the function f of x is the function g of x is the absolute value of f of x. So now we're talking about the absolute value of a function. And the function g of x can be written as the following. Well, let's use an example to discuss this. Let's say that f of x, just for example, that f of x is x plus 4. Well, then g of x is the absolute value of x plus 4. Or another example, maybe f of x is 4x minus 5. Then g of x, I'm saying g of x is the absolute value of f of x. Then that means that g of x is the absolute value of 4x minus 5. Okay, what this tells me, since this is an absolute value, g of x is going to end up being positive. If f of x turns out to be positive, if I solve x plus 4 and it turns out to be positive, g of x and f of x are going to be the same. Therefore, g of x equals f of x when f of x is greater than or equal to 0. So if I solved this out and found it was 0 or 1, 2, 3, 4, any positive value, g of x and f of x are going to be the same. However, what might happen is I solve out x plus 4 and it's a negative value. Therefore, if I end up with a negative value inside here for x plus 4, when I take the absolute value of that, I'm going to have to take the opposite. So if x plus 4 turned out to be negative 3, g of x would be the opposite. G of x would be 3. Therefore, g of x is negative f of x when f of x is less than 0. So if f of x turns out to be a negative number, to find the absolute value of that, to find g of x, I'm going to take negative f of x. So for results of f of x where f of x is greater than or equal to 0, g of x is the same. It equals f of x. For values where f of x turns out to be negative, then I need to take negative f of x in order to get my result for g of x. Now, talking about how to solve absolute value equations. When I look at a very simple equation like this, then I can think about what it's really saying, what the absolute value is really telling me. What this is telling me is that the absolute value of x plus 3 equals 5. So the absolute value, since the absolute value of x plus 3 is 5, I can look at this two ways. I realize that the expression x plus 3 equals 5, or that the expression x plus 3 equals negative 5. If it turned out that x plus 3 equals 5, then when I take the absolute value, I'd get 5. If I take the value of x plus 3 and I work it out and find out it equaled negative 5, when I put it in here and get the absolute value, I also get 5. It's analogous to the situation we talked about before. If I said the absolute value of x is 4, then x equals 4 could equal 4, because that absolute value would be 4, or it could equal negative 4, because that value comes out to 4. So looking at this, I know that this expression in here, x plus 3 either equals 5 or negative 5. So the way I'm going to approach this is absolute value equations is 1, split the equation into two parts. And this first part is going to have this expression equaling the positive number. The second part is going to have the expression equaling the negative number. Then solve both equations. So rewriting these, I have x plus 3 equals 5, and I also have x plus 3 equals negative 5. It could be either. So I solve this first one, very simple. Just subtract 3 from both sides, and that tells me that x equals 2. Or I can go ahead and solve for this, x plus 3, and I'm going to again subtract 3 from both sides. That's going to give me x equals negative 8. So x equals 2 or x equals negative 8. And to prove this to yourself, let's go back and look at this original and plug in our values. Absolute value of x plus 3 equals 5. Let's let x equal 2. Substitute in 2 for x. That gives me the absolute value of 5 equals 5. That is true. Okay, let's check out our other solution for x. Again, plugging it into my original equation here, the absolute value of x plus 3 equals 5. So this time, let's let x equal negative 8. So negative 8 plus 3 equals 5. So the negative 8 plus 3 is negative 5. looking at this, the absolute value of negative 5 is 5. So this is also true. So both answers fit with this equation. So again, the way to approach these is to split them into two parts. Split the equation into two parts. Take the expression in here and let it equal the positive number. Take that expression and also set it equal to the negative number. Then solve for both. We're going to use the same approach here, and I'm going to start out by split the equation into two parts, and then I'm going to solve each part. Once you recognize that you have to split it into two parts, this is actually very easy. My first part is 2x minus 8 equals 16. And if 2x minus 8 came out to 16, I put 6, then this would be 16. The absolute value of that is 16. Or the other possibility is I work out 2x minus 8 and it comes out to negative 16. So if I said 2x minus 8 equals negative 16 and I put negative 16 in there, the absolute value of that is also 16. So both of these are valid. Once I've done that, I simply need to solve each part of this equation, each equation, each of the two parts. Okay, I have 2x minus 8. I'm going to add 8 to both sides to get 2x equals 24. Now I'm going to divide by 2. X equals 12. For the other equation that I generated, I have 2x minus 8 plus 8 equals minus 16 plus 8. So this gives me 2x equals negative 8. Go ahead and divide by 2. And you get x equals negative 4. And you could check that by plugging it in, and you would find that if you plug 12 in here, you'd get 24 minus 8 is 16. And x equals negative 4 would give you negative 4 times 2 is negative 8, minus 8 is negative 16, and the absolute value of that also equals 16. So 24 minus 8, 16, absolute value of that is 16. Negative 4 also works. So again, simply split the equation into both parts and then solve each part. All right, in example 2, we're going to approach it by splitting this into two equations. The first equation is going to be negative 1/3 x minus 8 equals 24. Or you could have the equation negative 1/3 x minus 8 equals negative 24, because 24 would give you an absolute value of 24, and negative 24 would also give an absolute value of 24. Going ahead and solving both of these, I'm going to add 8 to both sides to get negative 1/3 x equals 32. Then I'm going to multiply both sides by negative 3 in order to isolate x, and that's going to give me x equals negative 96 for this equation. For the second equation, I'm going to also add 8 to both sides, yielding negative 1/3 x equals negative 16, and multiplying both sides by a negative 3 to give me x equals, and then it'll be negative 3 times negative 16, so that'll be positive 48. So possible values for x that would satisfy this equation would be negative 96 or 48. Either of those values would result in an absolute value that's equal to 24. In this example, we're going to graph the function g of x is the absolute value of 3x minus 4. So we talked before about functions g of x which are the absolute value of a function f of x. Before we start graphing, it's helpful to have a general idea of what the graph is going to look like. And it turns out that this graph will be V-shaped. And it'll intersect somewhere here on the x-axis. Notice that there are no parts of this graph in the lower two quadrants. And the reason is g of x is always going to be positive. Since g of x is the absolute value of f of x, it's always going to be positive. So the way to approach these is to pick values for x, and you need to pick both positive values for x and negative values. Looking over here, I see that I have some negative values for x, although g of x comes out to have positive values. I do have negative values for x, so I'll only end up with part of my graph if I don't pick negative values, and I also need to pick positive values. The other thing I want to find is this point, the point of the v, the point where this graph intersects with the x-axis. So let's talk about how to go about this. First, I'm going to just pick some points for x and solve for g of x. And x, if I let x be -2, I can solve this out, and that would give me -6 minus 4 is -10. But the absolute value of that is 10, because g of x is always going to be positive. -1, that would give me -3 minus 4, that's -7. The absolute value is 7. If I let x be 0, I get -4 in here, absolute value is 4. Now let's choose some positive values. If I let x be 1, that gives me 3 minus 4, which is -1. However, the absolute value of that is 1. A couple more positive values. 2, if I insert 2 in here, I'm going to end up with 6 minus 4, and that's going to give me the absolute value of 2 is 2. And finally, 3 times 3 is 9, minus 4 would give me 5, absolute value 5. Now, the other thing I want to find out is where this point is going to be, where the point of the v is. So to find the point of the v, let g of x equal 0. Okay, so if I let g of x equal 0, then the absolute value of 3x minus 4 is 0. And then I go ahead and solve this equation. So 0 equals 3x minus 4. Add 4 to both sides. X equals 4/3, or x equals 1 1/3. So when g of x is 0, x is going to be 4/3. I can put that over here. Now, I have a bunch of points, including where this point of the v is, so I can go about graphing. And I'll start up here. I don't even have to worry about labeling this lower part of the y-axis because I know that I'm not going to have any points over there. When x is -2, g of x is 10. When x is -1, g of x is 7. Hits right about there. When x is 0, g of x is 4. When x is 1, g of x is 1. When x is 2, g of x is 2. So I see that somewhere in here I've got to have my point of the v, or I'm not going to be able to make an accurate graph. So I've gotten down to right here. Let me look right here where my point is. When g of x is 0, x is -1 1/3. Okay, so now I'm going to have a nice V-shaped graph. One more point. When x is 3, g of x is 5. Now all I have to do is connect the points. So when graphing a function such as this, find the point by letting g of x equal 0, find the point of intersection with the x-axis by letting g of x equal 0. Then use some negative values for x and some positive values for x until you have enough information to graph out this V-shaped curve. In example 4, we're going to graph the function g of x equals the absolute value of negative 1/2 x plus 3. Again, I know that I'm looking for a graph that's going to end up V-shaped. So I need to find points along here, and I also need to find the point of the V. So I'm going to find some values for x. And I'm also going to make sure that I find the point. And remember, that point right down here is going to be when g of x equals 0. So I'm definitely going to solve for that. So picking some values for x, when x is negative 4, g of x turns out to be 5. When x is negative 2, y is, or g of x is 4. When x is 2, g of x is 2. And now let's solve out a couple just to show how this is being done. So for my next point, I'm going to go ahead and pick 4. So I'm going to let x equal 4. So it's the absolute value of that expression, which is negative 4 divided by 2 gives me negative 2 plus 3. So when x is 4, g of x is the absolute value of 1, so g of x equals 1. Okay. Another point I could pick, a bigger point just to make sure I have plenty of points on here, would be 8. So g of x equals negative 1/2 times 8 plus 3. So g of x equals the absolute value of negative 4 plus 3. So g of x equals the absolute value of negative 1, which is also 1. The last thing I'm going to do is to let g of x equal 0, and calculating that out, that's going to give me 0 equals negative 1/2 x plus 3, or negative 3 equals negative 1/2 x. So I'm going to end up with multiplying by both sides by negative 2, x equals 6. So I know that when g of x is 0, x is 6. Now I have plenty of data to work with to find this graph. Starting out with this point right here, okay, when x is 6, g of x is 0. So I know I'm going to have a line up here and a line up this way. When x is negative 4, g of x is 5. Negative 2, 4 is my next point. 2, 2, 4, 1, and then 8, 1. Because it's going to have a line going to the left, and then another line going to the right. And I could take a couple more points out here to find a little bit more of this, or I could just extend it out based on these 2 points. So again, when you're graphing a function such as this, find negative values for x, find positive values for x, and let g of x equal 0 to find the point of the v. Thanks for visiting educator.com. And I'll see you soon.